Welcome to today's GATE video. So myself Senthil, I am working in Department of Information Technology in SC Engineering College. So today's section, what we are going to see about a double linked list. Okay. So in this section, so what we are going to discuss is about the double linked list creation, double linked list insertion at the beginning and insertion at the end, and deletion at the beginning, deletion at the end, and finally how we are going to display a double linked list. So before we are going to start, so I am going to give a brief introduction about why we going for double linked list. So in single linked list, the main disadvantage is about, so you can move forward in a single direction in the single linked list, but you cannot go backward direction, that we call as reverse direction in single linked list. So for that reason, we are going to for double linked list where you can go forward as well as you can go backward. Okay, so this diagram shows the structure of a double linked list. So in this double linked list, you will have three main parts. The first main part is about the center data information, where you are going to store the value in a particular address. So the data left and right side, you will have two pointer. One we called as the previous pointer, and the next one we call as the next pointer. So once I told you the pointer, so pointer is nothing but you are going to store the address. Okay, we all know we are going to store the address. Here this previous pointer is going to store the previous data address. This next pointer is going to store the next node address. This is the main concept for double linked list. So let us consider a basic example here. Here I have inserted three node in the data linked list. So that is nothing but node 25, second node is 35, and the third node is 45. So here the first node, okay, kindly you can make a note of it. The first node of the linked list will be the header node, and in that you will have the previous node and the next node. The first node of the header node always be null, okay, and the next node will be stored the address of the next node. Here these three values, the value 25 will store the address 5010, and value 35 will store the address 5028, and the value 45 will store the address 5081. Okay, these are the memory location where we are going to store the address. So you can see this example, you can easily understand that. So in this node 35, you will have the previous pointer and the next pointer. So previous pointer means it stored the address of the previous node. Here 5010 it will be stored. Okay, and this next pointer will store the address of the previous node. Okay, so that value 5081. So with the help of this pointer concept, we are going to access the data. Okay, we are going to access the data with the help of the address. Okay, here the basic code I am going to declare here, where I am going to have the information data. The information data is nothing but the data information that where we are going to store the data, and struct node star previous, struct node star next. As you all know, star is nothing but the pointer concept. With the help of the address, we are going to access the data. Okay, this is the basic structure of a double linked list. So first we are going for creation of a double linked list. How we are going to create a node in a double linked list? Let us consider. So already we have a three node. So this is a node 1, node 2, node 3. As I told you before, the first node will be always, they are called as a head node. Head node of the previous node will be defaultly null. Okay. Here we are going to create a new node. Okay, so how we are going to create a new node? With the help of this following coding. Here int I and n I am going to declare. N is nothing but the number of nodes that we are going to create. I is nothing but the initial values I am going to initiate it. And the next is printf, enter the number of nodes. So how many nodes I am going to insert, I am going to create. So I can give, and the value will be taken by in the n as well as. Next I am going to print the value. So this part, the step 1, step 2, step 3 and step 4 is very important part. So we will go by step order. First step 1. So I am going to create a memory allocation. So for the memory allocation here, it is equal to start node of malloc of size of start node. Here the step 1. So once this line has been executed, memory location has been created with the help of the memory address 5030. That is the step 1. Step 2. So I am going to enter the value. So value I am going to get as an head information. So head information is nothing but this data. So the value I am going to give is 10. So 10 will be stored here with the help of the address, in the address 5030. Then I am going to set the previous node and the next node. So this is the head node. So head of previous node will be null defaultly, and the head of next node will be null defaultly, and I am going to set this head as an old node. I am going to set this head as an old node. This is how we are going to create a node in a double linked list. So far we have seen a single node how we are going to create. So if I want to create multiple nodes in a double linked list, the same thing what we are going to use, the same coding, but we are going to declare inside the for loop. So how many nodes here? For I is equal to 1, I is lesser than I plus plus, n is nothing but the number of nodes, and I will be initiated from 1 till the condition I have to given. Okay, so more number of nodes I can be created with the help of this loop concepts. Okay, next I am going to insert. So far what we have seen, how we are going to create a single node and how we are going to create a multiple nodes. Next I am going to insert a node at the beginning. Okay, so how we are going to insert the node? Let us consider a simple example here. So we have two node already. So node 10 and node 40. Node 10 will store in the address and node 40 will store in the address. You all know the starting node we will call as an head node. The head node will have the previous node defaultly null. Why we are setting it is defaultly it is null? Because there is no node in the previous, so that we are going to set it as a null. Okay, so let me look at the coding. So I am going to declare initially element. The element is nothing but the new element I am going to insert in the particular double linked list. Okay, next I am going to enter the element. Okay, as I know, so for the memory allocation, okay, first I am going to get the memory allocation and I am going to get the element, and this element will be assigned to n of information. So n of information is nothing but the data. So this node I am going to consider as a n, name as a n. In the nth node I am going to insert the data 60. So for this step 1 and step 2. Next what I am going to do is this is the node that I am going to use here. Okay, this is the head node already here, and the new node I am going to insert at the beginning, and this node will consider as n. Okay, so this node has been created and this node has been created. The step 3 and 4 gives the link between step 3 and 4 will give the link between n and the header node. So you all know, so this is the next node and this is the previous node. So first we are going to give n of next is equal to head. So n of next is equal to head. So this link will be created. Next, head of previous is equal to n. So head of previous equal to n. So this link will be created. So that's all. Okay, this two line. Okay, the step 3 and 4 gives the link between the n node and the head node. So this node has been inserted, and as I told you, so head is pointing here, n is here. Then we are going to change this head node as to this node, because always the first node will be head. Okay, for that I am going to assign n is equal to head. So here the head will be moved to here. So this is how you are going to insert a node in double linked list at the beginning. Okay. next. So insert the node at the end. So here the same concept what we are going to use, but we are going to insert the node at the end. Okay, let us consider three nodes: node 60, node 30 and node 40. Okay, and we are going to insert the node which is going to at the end. Okay, so first node we already all know. So first node also already it is an header node, and I am going to assign as a P. Okay, P is a pointer where I am going to assign, and this P node will be assigned to the header node. Okay, so for that the same coding we are going to be executed. Here what I am going to use, so while P of next is not equal to null. Okay, while P of next is not equal to null, that means P of next is not equal to null. When it comes, so this P node will be moved to this last node until it becomes null. So this is the concept. Okay, so this pointer P will move here. You can see here. So for this you are going to use this while loop. So how it going to work? It is true, then P is equal to P of next. So P is equal to P of next. Then, so for the first iteration. The second iteration, P of next is not equal to null. Yes, it is not equal to null. You have some value. So then the condition became true. So P is equal to P of next, then it will move here. Then here, okay, P is not equal to null. We are going to check. Here the P is equal to null. P of next is equal to null. So here the condition became false. So it will come out of the loop. Now the pointer P will be present here. Here we are going to insert the new node. So for that we are going to, here you can see. Okay. So this is the P node, and this is the new node I am going to insert. The same concept. Okay. So P of next is equal to n, and n of previous is equal to P. N of previous is equal to P. Okay. So the connection has been established, and the last node, okay, the last node of the next will be null. So n of next is equal to null. So with the help of this three line, okay, so that is P of next is equal to n, and P of previous is equal to P, and P of next is equal to null. So with the help of this three coding, we can insert this node at the end. So far we have seen insertion at the beginning and insertion at the end. Okay. Next we move on to deletion. So in this concept we are going to delete a particular node. Okay. So deletion of a particular node in the double linked list will take place of three types. One is deletion at the beginning, and second one is deletion at the end, and third is about deletion at the any values, any position. Okay. In today's section we are going to see deletion at the beginning as well as deletion at the end. So okay, let us consider, now we are going to see deletion at the beginning. So we are going to delete this starting node. Okay. So let us consider three nodes as we shown in this figure. Okay, 60, 30 and 40. So totally three nodes are there. So here we are going to delete this 60 node. Okay. So as we know, the first node always it will call as a head node, and I am going to assume as a pointer P. Okay. Here the coding is, so I am going to assign this head node as a P. So it will be pointing. Then I am going to assign head of next. Okay. So next I am going to assign. So if I am going to delete this node, the header will be pointing to the next node. For that I am going to giving this line. So head of next is equal to head. So this is the head node. Head of next is equal to head. So this head will be moves here. Okay. This is the head node because we are going to delete this particular node. So how we are going to delete this particular node means this node of next is equal to null, and this node of previous is equal to null. Okay. So where we can see the coding, this is the P node. So P of next is equal to null, and P of previous is equal to null. With the help of this two line, we can set this node as free. So that is a formula to delete a particular node, that is free of P. So once this line has been executed, this node has been deleted. Okay, and we are going to travel into the free. Okay, so this node has been deleted, and this node will be act as a head node. So head node of previous defaultly it will be having null node, as I told you before. Okay, so this is how the deletion is going to be happen in double linked list at the beginning. The next we are going to see about the deletion is going to be done at the end of the node. Let us take the same example. So 3 nodes I am going to take. So node 60, node 10 and node 40. So each node value will be stored under the particular address. Okay, so the first node will be pointing to the head node, and the same thing we are going to assign so P node also. So this is the P node and this is also a head node. Okay, first I am going to check the P and it going to move towards the last node. Okay, how we are going to check? So P is going to assign as a whole and P is going to assign as a head. Then while P of next is equals not equal to null. So P, this is a P node, P of next is not equal to null, condition true. Then I am going to move P is equal to P of next. This condition became true, so P pointer will be moved to the next node, that is P is equal to P of next. Here I again am going to check P of next is not equal to null, condition true. P of next is not equal to null, this condition true. Then P is equal to P of next. The pointer P will be moved here. So here with help of this line, so the pointer will be moving here. Then once again the third iteration, P of next is not equal to null. Here the P of next is equal to null. So the condition became false. So condition became false. The pointer will be facing at the last node. Okay, the pointer will be facing at the last node. Then what we are going to do? This node I am going to be deleted. Okay, this node will consider as a P and the previous node will be considered as a old. The same concept. So what I am going to do? The old of next is equal to null and the old of previous is equal to null. Okay, so old of next will be null and the P of previous is equal to null. Okay, so this point I am going to become null and this point I am going to become null. So this what address became null, so I can remove this particular pointer. Okay, that is the particular node. Okay, with help of this two line, so I can remove this and I am going to set free as P. So this P node has been deleted. So this is how the P node has been deleted and the deletion has been done in the end. Okay, so once again I will tell you a quick explanation about how the deletion is going to be done at the end. Okay, so first we are going to identify the header node and I am going to assign the header node as a P. Okay, so then I am going to traverse the P node to the end because I am going to delete the node at the end. So for that I am going to use this formula, that is this for loop. Okay, so with help of this for loop, the P node will starting here and it will be moved to the end of the node. So once the P node will be pointed to the end node and the previous node will be the old node. So this is the P node and this is the old node. Okay, so once this has been identified and we are going to set this P node as P, so this nothing but this is the old node, old of next is equal to null and the P of next is equal to null. Okay, once this two address is going to be null, so the entire connection will be disconnected and we are going to remove this P node. So this is how the deletion has been done in end of the list, that is double linked list. Okay, so far we have seen insertion at the beginning and insertion at the end and deletion at the beginning and deletion at the end. So the last part is about we are going to display. Okay, so as I told you, so in double linked list you will have two options. You can move forward and also you can move backward direction. So for displaying the data they are going to present inside the double linked list, you can display in forward direction as well as you can display in backward direction. Okay, so first we can see how we are going to display the data nodes that is in forward direction, that is 25, 35 and 45. So how we are going to display in forward? The same thing, let us consider three nodes. So each node consists the value so of 25, 35 and 45. So each node will store under the memory location. Okay, and defaultly the first node we call as a head node. The head of previous will be default, it will call as a null, and the last node of next defaultly it will set as a null. Okay, so here what we are going to do, so here this head node I am going to consider as a P node. Okay, that is head is equal to P, I am going to set. Then I am going to print the output as the list is. Okay, so the output it will be print like the list is 25, 35, 45. So I'm going to print in forward direction. How it going to happen? So I'm going to use a while loop. While P of next is not equal to null. So P of next, this is a P. P of next is not equal to null. Okay, after this condition will be executed true, and then I'm going to print this P of information. This P of information is 25. So 25 value will be printed. Next again, P is equal to P of next. This pointer P will be moved to the P of next with help of this address. This address, based on this address, the P will be moved to the next node. Okay, here the pointer is here. Okay, now again the loop will be executed. P is not equal to null. Here the P is not equal to null. Okay, so the condition is true. Then I am going to print the same thing. I am going to print the value 35. Once again, then P is equal to P of next. Then the pointer P here, it will move to the next node with the help of this address. Okay, so now the pointing will be here. The pointer P will be here. So the same condition I am going to check. P is not equal to null. Okay, here P is not equal to null. The P is equal to null. The condition became true. So the condition became true. It will come out of the loop. Okay, this is how the values will be printed. Okay, in forward direction. So the second type is it will be printed in the reverse direction. The same concept that we are going to use. Let us consider three nodes. Okay, node 25, node 35, node 45. Here what I am going to do is, so I am going to print the value in reverse direction. So 45, 35, 25, it should be printed. So how it going to be work? It will see. Okay, let us consider the first node will be head, and I am going to consider this head will be the pointer P. So head will be assigned to the pointer P. So first I am going to do, what I am going to do is, this pointer position will travel from the first node to the last node. For that I am going to use this for loop. Okay, sorry, I am going to use this while loop. With the help of the while loop, the pointer P will be moved towards here. Okay, so for that I am going to use this while loop. Then once the pointer P will be moved here, then the same thing what we have seen in the forward direction, same thing, while P is not equal to null. Okay, while P is not equal to null, the condition became true. It going to print the P of information. So it will be print P of information is 45. Here in backward direction, the only difference is P is equal to P of previous. In forward direction, P is equal to P of next. Okay, so in backward direction we are going to give P is equal to P of next. So P is equal to P of next means the pointer will be with help of this previous address. Okay, with help of this previous address, the pointer will be moved to here. Okay, once the pointer will be moved here, we are going to again the second iteration condition became true. It will be print 35. Next P is equal to P of previous. With help of this previous address, it going to move this pointer here, and it will be displayed 25. This is how the pointer will be moving backward direction with help of this previous address. I am going to print the value. This is how the value is going to printed in the reverse direction. So this is the main advantage for the double linked list, where you are going to move forward as far as the backward direction. And one of the main example for this double linked list application is your playlist in Spotify. So in Spotify, where we can listen or learn about the new songs, or you can have some set of data, you can move forward or you can move forward. You can create a playlist in the Spotify where you can play the next song, or you can play the previous song with the help of this double linked list concept. Okay, so far we have explained about how we are going to create and how we are going to insert the value, and how we are going to delete the values, and how we are going to display the values in the double linked list. Next we move on to the gate questions. Okay, so the first gate question what we will see, okay, which of the following information is stored in each node of the standard double linked list? So each node, what are things we are going to store? Okay, option A, value of the node, yes. the value of the node will be stored. Option B, address of the next node. Yes, the address of the next node will be stored. Option C, the address of the previous node. Yes, the address of the previous node. As I told you before, so in a double linked list structure, you will have three main parts. The center part will be the data, and the right part of the data will be the next. The left side of the data will be the previous. This next and previous node we call as a pointer node, where you are going to store the address. This three option is correct. Okay, so directly we can tick the D option, that is all of the above. The second question is, what is the main disadvantage, what is the main advantage of double linked list over a single linked list? As I told you before in the starting of the class, what is the main advantage of double linked list over single linked list? Here, in single linked list, you can move only the forward direction. You cannot move the backward direction. But in the double linked list, the data can be moved forward direction as well as the backward direction. Okay, that is the main advantage. So we can check with the option here. Okay, it uses less memory per node. It is not a correct one. It can be travels in both forward direction and backward direction. So this is the correct option. Okay, the option B is correct here. Next we move on to the third question. Okay, which of the following statement is false regarding a standard double linked list? Okay, we are going to check the false. Okay, so first thing, every node store links to both previous and next node. Okay, it is true. Then it takes more memory space than a single linked list. Yes, it is a true. Then the previous pointer of head node typically pointing to null. Yes, it is true. Then the last option is, it allows the binary search to be performed effectively in O log n. So O log n will be using the mathematical calculation, but this concept will not be implemented in double linked list. I think so option D is the wrong one. So we'll check with the option. Answer is D. So D is the wrong one. Okay. And move on to the fourth question. Insertion of an element at the end of a linked list required the modification of how many pointers? So we are going to insert. Okay, insert the element at the end. So insert the element, what the concept we are going to use? The pointer concept. So pointer will be moved to the last node. So only one pointer concept we are going to use. So in this option, the option D will have the one answer. So the correct answer is 1. The fifth question, a double linked list node can be implementing using the strut. As we have seen the coding. So strut, with help of strut we can use this double linked list, and with help of the class, okay, Java programming, we can use a double linked list. Okay, and I think both A and D will be the correct. Okay, option C will be the correct, because this both concept we can use in double linked list. Okay, so sixth question, which of the following sorting algorithm can be applied to linked list? So sorting algorithm we all know. So we are going to sort the algorithm in ascending and descending order. So first we go with the merge sort. So merge sort, how we are going to work? So divide and conquer method. First you are going to divide the input elements at a single element, and you are going to arrange in ascending order. So the values will be moved forward as well as the values will be moved backward. So this merge sort will be one of the main application in double linked list. Then insertion sort. So insertion sort also you are going to insert some values and you are going to sort. So these are the main applications in double linked list. Then quick sort. So in quick sort, what you are going to do, you are going to identify the const value. So according to the const value, you are going to sort. Okay, in forward or backward direction. So I think all these three sorting algorithm will the applications of double linked list. So option D is correct. Okay, so far we have discussed about all the questions which has been asked by the gate, and we will continue in the next section. Thank you all.